back to BD Cycles. My name is Logan, and today we're going to be going over the fundamentals of TIG welding. So, the three things that we're going to do in this video is that we're going to do a bead with no filler metal, bead with filler metal, and T-joints. This should get you pretty well started on learning the TIG welding. And at first, it's not going to look that great. It's going to take time and practice. So, a little bit about my background. I TIG welded for about a year straight at my very first welding job. I was repairing castings for petrochemical companies and other companies such as that. And so that was my first introduction to TIG welding, and I only went through 2 weeks of schooling. That was to help me pass my x-ray tests. And then the next job I had was welding on pressure vessels for a large helium company. And then now what I do is I do millwright work. So all throughout we do TIG welding, MIG welding, stick welding, and all other types of welding. Welding is pretty much what I do, and I enjoy it, and it unlocks a lot of potential in building bikes, cars, and anything else. So that's pretty much it. So the first thing we're going to do is run a bead with no filler metal. So to do that, you're going to need to do a couple of things. The first thing I'm going to go over is sharpening your tungsten. As you can see, it's to a very sharp point, and I like to run it that way because of my x-ray certifications and my background. So what you're going to do to get your tungsten this sharp is the best way is with a bench grinder and a drill. And so what you're going to do is you're going to chuck this up in the drill, and you're going to get it as high of an angle on the bench grinder as possible, so then you get a nice sharp tip. Alright, so the next thing we're going to be doing is setting up our TIG welder. So the very first thing you're going to do obviously is turn it on. This Dynasty takes a little while to boot up. And so you're going to want to be on DC. If you have a high frequency, this is high frequency impulse. And then for carbon, you're going to want to be on DC, and remote standard. That pretty much means that everything I do with my thumb switch is going to be mirrored by the voltage over here. Then this machine also has a couple of other interesting features. It has post flow, which is how long the gas stays on after you're done welding. And then for AC, which it won't let me show you, I'll switch it over just to show you. It has balance and frequency. And another thing is when you're hooking this up, if you have a machine that has a plus and a minus on it, you need to have your ground on the positive. I know that sounds backwards, but all TIG welding is done on DC electrode negative, which makes the TIG torch the negative side. Now there's a connection here where your gas comes through and into your hose. You want to make sure all this is tight. You don't need to kill it, but you need to make sure it's tight. And then there's another fitting on the back of the welder here that you're going to have to make sure is tight, as well as the one on the bottle. So now to set up your gas, you're going to turn your bottle on. Must be pure argon for what we're doing, unless you're doing aluminum, and then you can have some helium. And this bottle's at like 700 psi. And so how I'm going to set my flow is I'm going to turn it on, turn my torch on, and it's at 25 cubic feet per minute, cubic feet per hour, and that's what you want for TIG welding with a gas lens like this. If you have a smaller gas lens, or you have a collet, then you're going to want less gas flow because it can cause turbulence. Alright, so now that you have your tungsten nice and sharp and your welder turned on and everything, you're going to want to get your stick out correct. I like to run a little bit more stick out than some guys. Some guys will have it sucked all the way in there like that, to where the end of the grind is right there. The rule of thumb is whatever the inside diameter of your cup is how much your stick out should be. So that's about my stick out there. And to tighten the tungsten, you're going to tighten this back cap. Inside of here, one second while I pull this out. Inside of here is this. This fits over your tungsten and is called your collet. It's what tightens your tungsten inside of your torch. So now that we have that stuck out, that's a little far, so I'll stick that back in. and we have our ground connected to our workpiece. We have our torch. I have my thumb switch here. And I have my machine set to 150 amps. I like that for just messing around because I adjust with my thumb switch, and you'll learn as you go. So, the next thing that you're going to need to do is clean your metal. I know that there's torch slag on here, and there's no sense in cleaning it off because of what I'm doing, but your metal needs to be nice and white like this. If you try to weld over the mill scale, which I'll show you, it can cause undercut, which is a pain, and it can cause failures. So, now that we have this, we'll be going over what we're going to do next. So once I get suited up, I'm going to put a filter on the camera. You're going to want your torch 90 degrees to your workpiece, just like this. And so as you're coming along, this first one we're going to do is just going to be a bead with no metal added, no filler metal added. And you're going to be watching the edges of your puddle. Do not watch the arc. I normally go back and forth just to make sure it's not sputtering or anything. But it's always nice to have your hand propped as close as possible so you can move your hand along. And I'm just going to run this. And one thing I learned with taking my tests is make sure that you do a couple dry runs so that you know that you're going to be able to make it all the way to the end. Alrighty, so now we're going to make our first weld. And we're just going to ride this along. I'm getting the puddle going to a nice size. Now I'm dragging it across the plate. Well, not dragging it. Not really too much push angle. Plus or minus 15 degrees. And I'm just watching the puddle. Who cares what the arc's doing? Too much. And just watch that puddle. You want to make sure the edges are nice and uniform, because that's going to give you a nice looking weld and quality. And so when I taper off, if there's filler metal, I go back over, I add one last dab, so then I don't get a crater crack. So as you can see, that weld is very nice and uniform except for the end where I started moving around a little bit. And that's what you're looking for. You want nice and uniformity. So my recommendation is you're going to start running beads, and you're going to do this until you can get them nice and straight and the uniformity is there. So what you're looking for in the uniformity is that there is the same width, because then you know that you're going the same speed. Now we're going to see what this looks like under the hood. So as you can see now, I'm establishing my puddle and I'm moving along. And as for arc length, that's how far your tungsten is away from the piece. You want it to be as close as you can have it without dipping your tungsten. Now I'm going to move over there. So with arc length is when you touch your tungsten to your piece, which you don't have to do, how far off you are. And so I'm normally about 1/8 to 3/16 of an inch off, and it's all something that you're going to learn. The higher you are, the less control you have over your bead, and the wider it's going to be. The closer you are, the more heat and penetration you're going to have. I try to be as close as possible. So now the next thing that we're going to be learning is how to feed your filler wire. What I recommend you do is you learn this motion. You sit on the couch, watch your TV, and learn this motion over and over again. Move your fingers, push with your thumb. Move your fingers, push with your thumb. And I can do it with these fingers, and these fingers. It's all just learning the muscle memory. Once you get it down, it's like second nature. But for now, what I recommend is, so this is a piece of 16th filler metal, and so I'll get my puddle that width. The material we're using is 3/8 by 10. So you can sink a good bit of heat in there. And I might use 130, 145 amps of what I have this dialed up to. So what you're gonna learn how to do now is you're gonna take your filler metal and you're gonna stick out a piece that's long enough to go all the way across your piece. And so as you're going, you're gonna have your torch nice and perpendicular to your piece, 90-degree angle with your filler metal. You're just gonna dab, just keep on dabbing. And you're gonna add it to the puddle, which you'll be able to see when I do this weld. And so you're gonna dab and dab and dab and dab, and as you're going, it's gonna get eaten away, and so you will never have to feed any in. If you're using the correct wire for your application, you shouldn't need to push any in as long as your fit up is good. So that's what you're gonna see now. So now I'm gonna start my arc the same way. Get a nice puddle going, and then I'm going to start dabbing my metal in there. Dab, 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 dab. And I'm not pushing any metal in there. I'm just dabbing. And so what you're looking for is to keep a consistent arc length and a consistent travel speed. That's the main things that you're looking for to make a nice TIG weld. And you don't have to be the steadiest person. If you see yourself move around and miss something, then you just have to go back and fix it. So as you can see, we have good color there, and that's a little small. Now with this same wire, I can turn my amps way up and make it look way wider and flatter. So as you can see, that's still a very nice looking weld, and it's just the difference in how wide it is, and that's still filled nicely. All right, so now you're gonna see this from what it looks like underneath my hood. So I'm gonna initiate the arc. And what you want to watch for is if that puddle starts swirling around all crazy, then you know you're not giving it enough wire. And so that will be when you need to start feeding some in to control that, because when you have it way up in amperage and it starts getting all crazy, that's when you're going to get ugly looking welds. Now, as you can see, that's a very consistent, nice looking weld. So that's what you want to start looking for. That's just dabbing the wire in. That's not adding any filler. When we go to do our T-joint, then I will add some filler. So now I'm going to clean it up. So as you can see, now we got these pieces nice and tacked up. They don't need to be perfectly straight. So I'm going to run this first part of this bead with 16th wire. So again, I'm going to want to be on a 45 to each piece, creating a total of 90. And this time,
I am going to feed wire into it. I'm going to get the puddle going nice. I'm going to feed wire into it because it's the 16th wire.
So I ran that little bit. You can't see because of the smoke, but that looks very good. No undercut. So now I'm going to get out some 332 wire. Now 332 wire is probably better suited for this. So
again, I'm going to start my arc. And I'm just going to dab because this 332 wire is getting quite a bit more metal. And I'm just feeding that puddle. You want to dab and move the same amount every time you move. You want to watch right behind your puddle. Because you can see how the weld's going to turn out before it even does. So I'm not pushing any wire into there with the 332 wire. I don't need to. And when I need to grab another bite on my wire, because I was getting a little close to my hand, I just kind of rest it again and move.
as you can see with that weld, it's nice and tied in. There's no undercut, and it looks very good, in my opinion. I know there's probably some internet CWIs out there that'll say, oh, that doesn't look good. But what I'm trying to do with this pass, if this was 2 pieces, is to get it soaked in there. I don't want a lot of convexity. I want a nice, even transition, good fill. So now what you can do, let's say you're welding something structural.
You can come in here, I'm just going to do a short one. And you're going to have a pass down here that overlaps halfway. And so this is going to start filling it up. And this is your second pass.
So that's 2 there, as you can see. Very nice. And so my last pass, I'm going to kind of change my angle to go a little bit more towards the piece
at the top, because I want the metal to stick there. Wherever your arc goes, the metal will stick. Again, I'm overlapping this feed by about half. And so I add a nice big dab, I go back in over
my already melted metal. And as you can see, that's already much bigger. There's no undercut. There's no undercut on either of the pieces. So now you're gonna see it from what it looks like. Now you're gonna see what it looks like to me. Again, I'm using this 332 wire. I could use 16th, but I like to use the 16th for thinner stuff.
So I'm gonna have my torch angled right about in the middle of the joint, bumping it up to about 150 to start. Just to get that puddle going. And sometimes you will have to wishy-wash it back a little bit, back and forth, to get it to tie in nice. And again, I'm just dabbing.
So now that I have my first pass, I'll go ahead and show you like
what it looks like. So I'm gonna favor this bottom piece a little bit more. Weld the second bead on here. And so this kind of applies to when you're testing. A lot of guys will walk the cup. I like to run stringers. There's a time and a place for walking the cup, but running the stringer, I find you have a better success rate with your test.
And sometimes you do get a little sideways like I did.
But now we're going to come in at this angle. We're going to tie into this top piece. And as long as you are having good tie into your edges, and you don't end up with freak ferocity or anything like that, this is a surefire way to pass your flat test and your horizontal as well. Those tests are pretty easy. I think TIG is one of the easiest forms to pick up when once you have a firm understanding. And for me, where I got most of my understanding was from YouTube videos just like this. So I want to give back
and help out the young people that are learning how to TIG weld. So that weld there is just about as good as you're gonna get, and it's not perfect, but I think that it's pretty good for what it is. And so, in recap, you are going to dip your tungsten a lot. Get good at sharpening tungstens. I've gotten good enough to where I don't dip it sometimes all day. Sometimes I dip it 10 times a day. That's just part of life with welding. And if you dip it, grind it out. If it's something that's X-ray or critical, anything that's critical, if it's sheet metal or something else, you don't necessarily need to grind it out, but you do need to grind your tungsten. The nice sharp tungsten makes this whole process a lot easier. It makes your welds look 10 times nicer. So, have a great rest of your day. I hope that you learned something. If you have any comments, leave them down below. Please like, comment, and subscribe.